Hi, my name's Matt Disney, and I'd like to give you a very short pitch as to why you should come and do GEOG3051, Principles of Practice of Remote Sensing. So if you've done 2021, which is the remote sensing course, the second year course that Lewis and I run, you'll know me already. And if you don't, well, do come along anyway, but we need to talk about prerequisites. But the course is designed to give you a much more advanced look at remote sensing, in particular to try and understand the fundamentals of what it is that remote sensing can and can't give us. As you remember from 2021, one of the things about remote sensing is that what we measure is by definition remote and indirect and often not the thing that we're after. So what I'm going to talk about in 3051 is how we go from this wide range of satellite measurements, which are seemingly very interesting but very difficult to turn into useful information, into understanding what the information is contained in those signals and how we can use it in a very, very wide range of environmental and societal and geoscience and climate applications. So there's a huge range of new satellites available, and they provide a huge amount of new data, including observations on things like forest deforestation, forest cover, ocean surfaces, the sea surface temperature, the productivity of the globe, how much stuff is being produced through photosynthesis either in the ocean, on the land surface, food security, farming, agriculture. There's the whole geopolitical element of things in terms of surveillance and refugees and internally displaced people and conflict, and of course climate, which is one of the big applications. So short-term weather forecasting rather than climate, and of course climate itself, understanding both the immediate and long-term historical and future climate implications. So in order to do good climate modelling, you need good data, and you need data on how the surface is changing. So that's something that remote sensing does very well, how things are changing, what's happening, are the fires, disturbance, anthropogenic effects. We can look at landslides, earthquakes, ice sheets, so pretty much everything. So that's why remote sensing is interesting, because it deals with everything, pretty much, the atmosphere, and even beyond the atmosphere, out to the moon and the planets. But I'm not going to talk about that much in the course, but that is another aspect of remote sensing. So remote sensing gives us information on pretty much everything we're interested in. The only bits that we find difficult are the subsurface bits, so bottom of the ocean and under the surface of the terrestrial land surface. But even then we can say something about gravity, field strength, and the density of the Earth. So there's a huge range of applications. It's a fascinating and growing subject. European Space Agency and NASA and all sorts of other international and national space agencies are launching a huge range of new sensors that are giving us a completely new perspective on the world. And as you've probably seen from the news and Google Earth and these kind of things, they're not static, they're changing, and they're getting better very, very rapidly. And so I'll talk about some of the applications of that. And the course, the details, it's lectures and seminar sessions, and the assessment is via an exam at the beginning of term 2, 70%, and also 30% from an assessed poster. So I'll ask you to do some detailed research into a particular application of remote sensing and produce a scientific poster as if you were going to a scientific conference, and present it to me and to your colleagues in the class, and 30% of the coursework assessment will be based on that poster. So fascinating subject, loads to talk about. Please come along and do 3051. Thanks.